Are you seeing this screen? Bro, is it visible?
Yes.
So do you have previous idea little bit on the basis of differential equation? What do you know about differential equation? Why need to study the differential equation? What is the physical interpretation? And have you done differential equation before? I think first order, second order, higher order, every differential equation you have done in advanced engineering mathematics in second semester, I think. Can you remember that? Little logic you just tell me. For you do have here in your first semester first order differential equation. So first order differential equation, how many arbitrary constant it will contain in its general solution? Students, what is the physical interpretation of the ordinary differential equation? Tell me. You know equation, but why need to study the differential equation? Only 13 students. Slowly are coming. Okay. डिफरेंशियल इक्वेशन आइडिया है वो, इसका फिजिकल इंटरप्रिटेशन क्या है? Why need to study this? What it will indicate basically? Somebody just tell me. No. So you will not respond. Is it visual?
Yes, sir.
What is written here? In the title, what is written here?
Good, sir.
Euler's method. Very good. So in first order differential equation, it will contain in its general solution, it will contain one arbitrary constant. Suppose you are writing general solution y equals to c1 e to the power m1x. Okay, looks like that. Plus okay, like that structure. In that way, you have written the general solution for second order or third order or higher order c1 e to the power m1x plus c2 e to the power m2x, like that, isn't it? So on the basis of order, how much order that differential equation, on that basis same number of arbitrary constant will contain in the general solution. Now that arbitrary constant will consider infinitely many solution. Okay, means arbitrary constant you may consider arbitrarily infinite many times. So you will get infinite many curve y curve, and separately if you will try to represent all them separately, it will take you infinite phases. You cannot able to represent that infinite number of equations. To rewrite that infinite number of equations simultaneously with the help of a single equation, if you will use the derivative coefficient term, you may able to represent that infinite or system of curve in a single equation with the help of differential equation. So its physical interpretation indicate you that it will represent the system of curves. Okay, among them system of curves, suppose you do have one condition at x0 y0 is given, at x0 y0 is given. If you will put that condition in this general solution equation, so at x0 you will get y0. So from there you will get that arbitrary constant. Suppose that arbitrary constant you will calculate and you will find that c1. Okay, and that m1 is the root of the auxiliary equation. So this is the numerical value, that is not arbitrary constant. C1 is the arbitrary constant. So after putting that initial value what is given to you in the condition, you will get that arbitrary value in a particular value. And if you will put back that particular value in the general solution, you will get particular y equals to fx like curve. Y equals to fx like curve. That solution is known as particular solution. Okay, in that particular solution, suppose anybody will ask you calculate values of y at x equals to xp. Can you able to calculate that? If function is known, then after getting that function, obviously in that function you just put x equals to xp, you will get y. Is it clear?
Yes.
That same process we are going to discuss here. Okay, you do have a first order differential equation looks like this. What is written here? Along with a condition, initial condition is given to me. Means for this differential equation, you will get an infinite solution. In that infinite solution structure, you just put this initial condition. You will get a particular y equals to fx curve. In that curve, you have to calculate at some other point values of y at x equals to xp, like that type of things. Okay, so basically this information is nothing but a single curve, particular solution. And if this portion is not given to you, this will indicate general solution, means infinitely many solution. Along with infinitely many solution means that differential equation, if initial condition is given to you, means it is simply a curve. In that curve, you have to calculate values of y at some other x. Okay, logic is clear. Now you have to calculate, suppose y x equals to xp for this question. What will be this? Okay, now let's do whatever the first order differential equation is there. Try to write dy by dx term. Rearrange or do little algebraic manipulation such that bring dy by dx left hand side and remaining xy related term right hand side, and that term you just rename by function of xy. Can you able to rearrange that and can you able to do this? Obviously you can able to do this. It is the just rearrangement. Okay, after doing that, little theory I am telling you here. For any curve, suppose this is a curve y equals to fx. Okay, for any curve dy by dx, del y by del x at del x tends to 0, that is dy by dx. In limiting case, difference of y by difference of x, and x difference you are taking tends to 0, then it will be dy by dx at x equals to x0. Okay, means y difference, suppose that is y difference, this is x difference. In limiting case, that is the derivative at this point, and that derivative is tan theta. Suppose I have written tan theta, means if you will try to draw a tangent at this point, and that tangent is making angle along with the x-axis. That tan value is equals to derivative, and that derivative dy by dx is given to you as a function of xy, right hand side. In the question it is given to you. So in a function of xy, you have to put a in place of x equals to x0. So you may able to write this expression. Is this expression is logically correct? This expression logically correct or not? बोलो बाबू. So after that, I think it is correct. Okay. So you don't have dare to say it is yes or not. I think that much confidence still you are not building.
Yes, sir.
Okay, very good. I like it. Now, y difference I am writing y1 minus y0 in space length, suppose corresponding to x, x0 and corresponding to x1, y1. That values is given to you, and y1 minus y0, and in del x, x1 minus x0. That is suppose h, space length. Okay. So that is equals to, if I will put that x equals to x0 in several variable at right hand side, that will be f of x0, and at that point y is y0. So I am putting in the right hand side, that value is f of x0 y0. Okay. Now after doing this calculation, if this is the h, so y1 is becoming y0, that y0 I am bringing right hand side, and that h is again multiplied here. So y1 equals to y0 plus h f of x0 y0. Now actually that y1 I am thinking that is not result actually. That is I am thinking first iterated value. That is ultimate answer I am not thinking. I am thinking this is the first iterated value. So I may write that y1 exactly equals to, because this is the approximation value. So I am just omitting this, and I am writing this is y1 equals to y0 plus h f of x0 y0. So in original question, x0 and at that point y means y0 is given. X0 y0 is given. So f of x0 y0 from this question you may able to calculate. Okay. So f of x0 y0 is clear in the question. F of x0 y0 you may able to calculate. H you may able to calculate, and y0 is given. So with the help of this you may able to calculate y1. And y1 is nothing but values of y at x1. That is the basically values of y at x1. X1 and x1 equals to x0 plus h. That is y1. So a new y value you are getting. Suppose initially x0, at x0 functional value y0, that is given. With the help of that information at some other point, suppose that point is here, that is x1. At that point you are getting y1, means f of x1 is y1. Y1 you are calculating with the help of initial condition, and that is you are thinking the first approximated value. Now x1 is x0 plus h. So x1 is clear, y1 that is also clear with the help of initial condition. Now in the same way, with the help of x1 and y1, can you able to calculate y2 using that type of recurrence relation in same way in which we have done up to this much? And I will use that same recurrence relation. So to calculate y2, now x1 and y1 is clear. Okay, x1 and y1 is clear. With the help of x1 and y1, if I will use this recurrence scheme, I will calculate y2 as y1 plus h f of x1 y1. That is the second iterated value. Okay. Now in this process I may able to calculate values of y at x equals to xp, means yp will be yp minus 1 plus h f of xp minus 1 yp minus 1. That is the recurrence relation. In that way you have to calculate for any problems. Okay.
Yes.
Now in the question, step length will be given to you. On the basis of step length, you have to decide how many iterations you have to perform. Okay, how many iterations will be performed? It will be decided in the question on the basis of h value given to you. Okay, now I am just see nicely that recurrence relation. You just try to remember. Okay, y1 or yn will be yn minus 1 plus h f of xn minus 1 yn minus 1. In place of n, it is suppose p I have written, no problem. But that is the general relationship. So to get y1, y0, h, f of x0, y0. That is the recurrence relation. You just try to remember with the help of Euler's method how we will calculate this question. You just try to see. Okay. You just try to study or read this question carefully. Dy by dx is given to you x plus y. Okay, and y0 means at x0 value is 0, y value is y0, that is 1 is given to you. Means x0 is 0, y0 is 1. Then calculate y 0.2. From this information, again I am telling you, this is a particular curve. Particular curve means particular graph y equals to fx. Looks like that. In that fx, you have to put x equals to 0.2, and what is the y will be there. That is the idea. But that is you have to do with the help of Euler's method using this step length. So how many iterations you have to perform? You just tell me to calculate this. Means you have to reach up to this much. Step by step, you just increase x value. Initial x is, you just tell me, what is initial x? X0, 0. What is x1? What is x1? Bolo, x0 plus h. X0 plus h means what is that value? Are you watching this? Students, what is x1? You just tell me quickly. X0 is 0, x1 is x0 plus h is given to you. What is x1? दिखाई दे रहा बाबू?
यस सर।
बोलो कुछ, माइक अनम्यूट करो और बोलो। What is x1?
0.05.
0.05. Can you tell me what is x2? X2 is x1 plus h.
0.1.
0.1. Very good. Okay, you have to calculate this. That is, you have to keep in mind. Okay, means values of y at x equals to 0.2. Still, you are not getting x value 0.2. You are getting 0.2. Means at this point, with the help of x0, y0 is given to you. You can able to calculate y1. Y1 means values of y at x1. Y2 means values of y at x2 means 0.1. Now x3, you just tell me. X3 is 0.15 means values of at x3 you are calculating y means y3, that is values of y at x equals to 0.15. That is still I don't need. I need this value. So what is x4? You just tell me. X4 will be 0.15 plus 0.05 means 0.2. Are you getting my point? So values of y at x4, that is nothing but values of y at 0.2 means y x4 means values of y at x4 is 0.2. That is my question, and that values of y at x4 means y4 I have to calculate. Okay, so using initial condition x0, y0, you will get y1. After getting y1, using x1, y1, you have to calculate y2. After getting y2, using x2, y2, you have to calculate y3. After getting y3, using x3, y3, you have to calculate y4. Y4 is the answer. Is it clear?
Yes, sir.
Clear? Okay, that idea I am telling you. By watching the step length, you have to decide how many iterations you have to perform. Okay, it will be given to you in the question. Just to calculate that how many iterations you need, that is within the question or by watching the age value. Suppose you just tell me a rough question I am asking you here. If age equals to 0.1 is given to you, then how many iterations you have to perform for this same question? Age equals to 0.1 is given to you, then how many iterations you have to perform for this same question? Bolo, h equals to 0.1. That is the verbal question. H equals to 0.1 for the same question. How many iterations you have to perform? Quickly, you just tell me. No answer. H equals to 0.1 means value of in first iteration what you will get? X0 is 0. X1 is 0 plus 0.1 means 0.1. Values of y at 0.1. Then x2 is x1 plus h means 0.1 plus 0.1 means 0.2 means y2 you have to calculate. Only after doing two iteration you may able to give the answer, isn't it? So h is less means you have to perform lot of iteration. H is more means you have to perform less iteration. Okay. अब तुम लोग इतना लेट से क्लास आते हो, कोई हाँ ना नहीं बोलते हो, तो कैसे होगा वो? कुछ तो बताओ, समझ में आ रहा कि नहीं? आ रहा। तो जो 0.1 h लेंगे तो कितना इटरेशन होगा वो क्विकली बोल दो, फटाक से माइक ऑन करो और बताओ। तब नो एक मतलब टीचर h equals to 0.1, how many iterations you have to perform for the same question?
Two, sir.
Two iteration. Very good. So here h equals to 0.5, so you need 4 iteration. And how it is needing 4 equation, step by step, that expression or description I told you here. Okay. Now you just use that recurrence relation of Euler method, what I told you. So y1 is y0 plus h, isn't it? Y1 is y0 plus h, f of x0, y0. X0 is given to you, x0 is 0. X1 is, sorry, y0 is 1. So f of xy, f of x comma y, that function is this. That is f of x comma y. So using this several variable function, you may able to calculate that value using x0 and y0 in place of x, x0 plus in place of y, y0. You just put, you may able to calculate this. What is h here? H is given to you in the question. Y0 is 1. So 1 plus h means 0.5 plus x0 plus y0. X0 is 0, y0 is 1. This is clear? Y1 already
Yes.
calculated. After getting y1, x1 is by default clear. X1 is x0 plus h. H increment will give you the x arguments. And that increment you have to do up to that much when you will reach this value. Then you have to stop. So what is x1 now? Y1 already calculated. X1 is x0 plus h. X1 is 0.05. Y1 is 1.05. With the help of x1 and y1, using the same recurrence relation, can you able to calculate y2? y2 equals to y1 plus h f of x1 y1. x1 is clear, y1 is clear. y1 you have calculated from previous line. That is y1 plus h 0.5 plus f of x1 y1. f of x comma y is the several variable function given question. Means addition x plus y. It will be given to for different question, different. So that several variable function you have to use for different problems to calculate these things. Okay. Now h is 0.5 and x1 is, so basically f of x1 comma y1 means x1 plus y1. x1 is 0.05 and y1 is you have calculated. After doing this calculation, it is becoming looks like this. Okay. ठीक है बाबू. After getting y2, x2 is also clear. x2 is x1 plus h. x2 is 0.1. y2 already calculated. With the help of x2, y2, you just calculate y3. y3 is values of y at x3. x3 is 0.15. That is I told you. But that is still not my answer. So I am calculating y3 with the help of x2, y2. That will be formula is y2 plus h f of x2, y2. x2, y2, both are clear. Several variable function is there. In that function, you just put these two value means addition. You will get y3. y3, x3 clear. You just calculate y4 with the help of x3, y3. y4 is y3 plus h f of x3, y3. Okay. y3 already calculated in previous line. h is given to you. Again, x3 means x2 plus h. In that way, you just calculate x3. x2 plus h means 0.15. That is already calculated in previous line. y4, that value is coming looks like this. That is the approximate. Since you are using here numerical methods, that is approximate value at this point. Values of y at x equals to 4 means x4 means x4 value is 0.2 and that is my answer also. That is the query point. Okay. You have to calculate, then you have to stop. That is the better approximate result in this method. 1.23. So whatever in this information you do have a curve, in that curve if you will put this value, that will be approximately this. Is it clear?
Yes, sir.
Okay. Now I am coming to some another methods. Okay. That is also important method, Euler's method. I am coming to another method, that is Runge-Gupta method. You do have two separate method in the same method, Runge-Gupta method. It's having the second order and fourth order. These two are important and in your syllabus. Okay. Beside that, on rough logic, I am telling you that Euler's method till now, what is we have discussed, this is sometimes known as Runge-Gupta method of first order. Okay, Euler method is sometimes known as, not sometimes, actually it is well known as Runge-Gupta method of first order. Beside that, you have to study these two methods, second order and fourth order. These two are in your syllabus. Okay. Okay, can you able to verify this? What is the answer you are getting? How will verify? For this differential equation, what is the answer you are getting? That is almost equal or nearby solution or not? That mathematics, do you have idea? Can you able to solve this is mathematically? What is the solution? We have got y at 0.2. That is, can you able to verify mathematically? That is not in your syllabus, but it is my asking point. How much mathematics you are knowing? That mathematics idea you do have, because this is very simple question. with the help of mathematics also you may able to solve. So first of all, can you able to solve this first order differential equation? In that differential equation, you just put this initial condition, you will get a particular curve. In that curve, you just put that value. That is the logic. Can you able to do this? And can you able to verify what is the answer you are getting? That is almost correct or not? First order differential equation solving idea have. Okay, beside that, actually, this is 1.23 answer in this method you are getting. That mathematics little bit I am telling you. So just try to see. You know the Bernoulli's form, first order differential equation Bernoulli's form. If you will do this equation, that is looks like this. Its integrating factor is this. If you will write the general solution, y into integrating factor equals to integrating factor into right hand side plus arbitrary constant. Since it is first order, so one arbitrary constant you are adding. This is the general solution. So after solving this integration, it is looks like this. Okay. In this solution, I am putting the initial condition at x0, y0 is given means 1. I am getting c value, c particular value. That c value I am putting here in the general solution. I am getting the particular curve y equals to function of x. In that function of x particular curve, I am putting x equals to 0.2. So I am getting looks like this type of answer. That is the exact 1.2428 looks like that, 0.55 like that. But in Euler's method, that is I got 1.23 looks like that. Okay, 1.23. That is the exact mathematical procedure 1.2428055 like that. But in Euler's method, it is coming 1.23. Just 1.223. So 1.24 and 1.23 is almost equal. Looks like. Is it clear? बोलो वो समझ में आ रहा कि नहीं? Students, ठीक है वो up to this much discussion, okay? Up to this much discussion, okay? No problem. बोलो.
Yes, sir.
Okay, so if I will write this recurrence relation of Euler's method, this is recurrence relation of Euler method is looks like actually yn equals to yn minus 1 plus k, and that k is f of xn minus 1 yn minus 1. Is it okay?
Yes, sir.
If I will write yn equals to yn minus 1 plus k, where k is h f of xn minus 1 yn minus 1. In that way, our recurrence relation is keep continuing. You just see. That is I have written k. Okay. So yp equals to yp minus 1 plus k. K is this. Okay. So this is actually k calculation is simply one term. If that k is built from average of 2k, then it will be the second order, and average of 4 different k, that weighted average of 4 different k, it will be fourth order. And since in Euler method it is simply 1k, and that is why Euler's method is known as the Runge-Kutta method of first order. Okay. So what is the method we till now discussed? That is the Runge-Kutta method of first order also, but famously or very well known as Euler's method. Means after developing that method, later in Runge-Kutta they has developed for the higher order. But initially Euler has developed this method. That is why Euler is famous in this name. But sometimes it is known as, or in the question it will be asked to you, find out or what is Runge-Kutta method of first order, means that is nothing but Euler's method. Okay.
Yes.
Okay. Now that second order I am telling you just quickly. That structure will be yn equals to yn minus 1 plus k. That k will be average of 2k. Okay, so first of all, y1 I am calculating. Y1 is y0 plus h. So y0, and that expression, if you will express that is in Taylor series expression, that is overall k, means basically y1 is basically y0 plus k, and that k is average of 2k, k1 plus k2 by 2. And how this k1 and k2 will be calculated? That formula is this. K1 is h f of x0, K2 is h f of x0 plus h, y0 plus K1. What is K1? Already calculated. So you may be able to calculate K1, you may be able to calculate K2 because h is given to you, x0, y0 is given to you. After calculating that K1, you may be able to calculate K2, h is given to you, f of x0 plus h. What is the coordinate you will get in that point, and y0 plus K1, what is you will calculate it. You in these 2 points, using that several variable function, you may be able to calculate K2. After getting K1, K2, find out its average. That average you just add along with y0. That will be y1. That is the process. And if you will write its program, it will be so simple. First you will calculate this, then this, then this, then this formula. You will get y1 so quickly. Okay. Logic is x0, y0 is given to you. With the help of x0, y0, first you will calculate y1. To calculate y1, this is the process. After getting y1 here also, x1, y1 is clear. Now same formula you have to adopt. Y2 will be y1 plus k. And that time k will be average of that 2k, means k1 equals to h f of x1, y1. K2 will be h f of x1 plus h, y1 plus k1, like that. And that general formula I am writing here. Okay, that calculation will be done with the help of a program, and that program I am trying to write actually here. You just try to see and watch. X0, Y0 is given to you. Suppose you have to calculate Yx n, means Yn you have to calculate. Okay. So that is my question. With x0, y0 is given, x0, y0 given, and dy by dx means several variable function f of xy is also given. This is my question. Now loop for second order Runge-Kutta method I am writing. Suppose f of for loop I am writing I equals to 0, I less than n, I plus plus. And first I am calculating K1. K1 equals to h f of x I yi. Then I am calculating K2, that will be h f of x I plus x I plus h y I plus K1. K1, K2 clear? You may calculate K equals to average of these two K. That function, several very function you have to define within the program or at the header also. So obviously this will be calculated numerically nicely. After getting K1, K2, you just calculate K. Average of these two K is this. Now, at the right hand side, it will consider n minus 1 value, maximum value n minus 1. So y, sorry, I need yn. So yi plus 1 will be yi plus k. So with the help of this loop, can we able to solve this problem? Means can we able to get yn? Can we able to print yn last value? What is yi plus 1? Print yi plus 1, that is the last value, that is the yn. With the help of this loop, can we able to solve this? Is it clear?
Yes, sir.
Is it clear? So program style also I told you, no problem. So initially you just define several variable function, take input x0, y0. So obviously the query point also you just take input, no problem. Or on the basis of the query point, you just define here the upper boundary. Means n maximum value such that yn will be the output. In that way, you just define here. And nicely, you just try to calculate this type of problem. And that is known as the second order. Second order means average of 2k in the recurrence relation. In the recurrence relation, only one case means Euler's method. Now, if it is fourth order, then it will be the average of 4k. And that average is not simple average. It is the weighted average. Means that 4k having different weight. So using the sum of the weight, you have to divide and it will become the weighted average. And that is, I am telling you, y I plus 1 will be k. And that k is weighted average of 4k, means k1 plus 2k2. In k2, I am giving 2 weight. In k3 also 2 weight. And in k4, 1 weight. How many weights I have given here? Total in 4k?